Alright, so to start the lesson off, I have two warm-ups here, and no, you don't have to write them. What I will ask you to do is to go ahead and, in the first one, find the mistake or mistakes, if there's more than one, and in the second one, go ahead and tell me, what did I do to go from this step to this step? So in detail explain how did I go from here to here. So go ahead and take a few minutes and think about it, and then I'll ask some volunteers for some suggestions and some answers to these. Alright, so let's start with number one, and go ahead and tell me what were the two mistakes that I intentionally made when solving this particular problem. And I didn't solve it to completion. I only went as far as the first step, and I made at least one mistake there. Alright, so there are two mistakes in number one, and they both have to do with combining like terms. And these were mistakes that I did see on the last quiz, at least a few of you make. So first of all, I'm dealing with the x terms. I'm going to combine my x terms. I have 4x minus 3x. This minus belongs to the x term. So what I can do is I can cover up my constant here, and I get 4x plus a negative 3x. No matter how you look at it, that's going to be just 1x. 4x plus a negative 3x, or 4x take away 3x, that's just 1x. So right here, I should have had just 1x or just an x. So that's right here would have been the correct value for dx. The second mistake was with my constants. Right here, 9. This minus belongs to the x term now, so I have to ignore it when I solve for my constant. So 9 plus 8 is 17. Not 9 minus 8, because that minus belongs to the x term, not the constant. So 9 plus 8 is 17, so that should have been 17 right there. And those were the two mistakes that I made in number one. Alright, go ahead and tell me what in detail did I do going from this step to this step in number two. Okay, so what you should have told me was that I first found the LCD, because I need to find the LCD in order to get rid of the denominators. I obviously got rid of the denominators, but how did I accomplish this? I found the LCD, which in this case is 16, one of the denominators. 16 goes into 16, 4 goes into 16, 8 goes into 16. And then my next step was to multiply both sides, or in this case every single term, by 16. When I multiply the first term by 16, it cleanly cancels out. 16 on the top, 16 on the bottom, I just get 9x. When I multiply the second term by 16, I can cancel out a 4 out of the 16 here, but I'll still have a 4 remainder left at the top, so 4 times 2x is 8x. That minus simply carries over. And when I multiply the last term by 16, I can cancel out an 8 out of both the 8 here and the 16, but I'll have a remainder of a 2 up top. 2 times 25 is 50. And that's how I went from here to here. Again, I'm not going to solve either of these two problems to completion, but hopefully once they are in this two-step equation form, that's no longer a problem. Alright, so let's go ahead and move on to the lesson itself. So this is a very simple problem from this lesson, which has variables on both sides of the equation. So far we've either dealt with an equation having just one variable on one side of the equation, but we also dealt, especially in the last section in 3.3, with equations that had 2 or even 3 variables, but they were still all on the same side. So you would just combine those terms and that would be that. We never dealt with the variable being on both sides of the equation. Now, thankfully, it works out in a very simple fashion. But remember, what was the rule for solving an equation? What is our end goal whenever we want to solve any equation? So go ahead and think about that and tell me. Well, it's to isolate the variable on one side of the equation. So the variable has to be all alone on one side of the equation. And having a variable on both sides presents a problem, because how do you isolate it on one side if they're on both sides? So you have to choose a side in a problem like this and confine your variable to that one side. In a problem like this, you actually have a choice. You can choose to leave your variable on the left side or the right side. And both cases work. A lot of people have different approaches that they like. For example, the book suggests one approach. I actually prefer a different approach. So I'm going to show you both, and I'll let you choose which approach to take when it comes to dealing with a problem like that. But the whole idea is that I want x to be either on this side of the equation or on this side of the equation, but not both. So first I'm going to show you my way, the way I like to work out a problem like this. I like to eliminate whichever x term is smaller or has a smaller coefficient. So whichever has the smaller number in front of it. That's the one I like to eliminate. So here I have 4 times x or 4x, and here I have x or 1 times x. This is the x with the smaller coefficient. And I find it almost always easier to get rid of the one with the smaller coefficient. There are a few exceptions, but for the most part, this solution works, or this strategy works for me most of the time. So what do? I want to get rid of this x, because I want all my x's to be only on the left side. That's what I've chosen. I've chosen left side. I'll show you next how to choose the right side, but I chose the left side this time around. So I want this x gone, because I want my x's to be on the left side. How do I get rid of this x? What can I do to get rid of that x? Well, there are 2 things you can technically do, but the easiest thing to do is to subtract x. Because what's x minus x? Well, x minus x is 0, just like 1 minus 1 or 2 minus 2. It's gone, technically. So that's one very valid strategy to eliminate that x. You can also multiply it by 0, but that's not a very good strategy here, because multiplying by 0 in an equation is kind of like a self-detonate, or like a suicide for that equation. It's going to destroy everything in the equation. So we try to avoid multiplying by 0 in an equation. So if you subtract the x from the right side, it's going to eliminate that x, right? X minus x, gone. Perfect. But remember, whatever you do to one side, you have to, that's right, do to the other side. Which means I have to subtract x from this side as well to keep that equation balanced. Okay, not a problem. So what does that yield? That's gone, because x minus x is 0. On the left side, I now have 4x minus x, which is 3x. The plus 6 carries over. On the right side, I just have a 0. It's okay, I can write 0. It's not a problem. Now I can solve this just like any other 2-step equation. I only have 1x, it's on one side of the equation. I'm going to isolate it. How do I do that? By this point, I'm not going to spend a ton of time on this. I assume this process would now be familiar to you. I'm not going to teach you how to solve 2-step equations. And then, of course, I would divide both sides by 3. And be careful right over here because negative 6 divided by 3 is a negative 3. Negative divided by a positive. Different sign division yields a negative answer. So negative 6 divided by 3 is a negative 2. And that's it. You're done. That really wasn't that much different than what we've done prior to this, except, instead of subtracting a number from a side, we had to subtract the variable from one side in order to get all my variables on another side of the equation. Now let's take a look what this looks like if I choose to keep my x on the other side, because that's what the book actually uses, and you're more than welcome to go that route. So what the book says, instead of keeping your x's on the left side, keep your x on the right side. Okay, perfect. How do I eliminate this one now? So I want to keep this x, I want to get rid of this x. How do I eliminate it? I subtract 4x, because 4x minus 4x, just like 2 minus 2 or 5 minus 5 is 0. It's gone. When you subtract the same value from that value, the only possible difference, it can be 0. Alright, but don't forget, I gotta do it from both sides to keep the equation balanced. Alright, that's good. That's a 0 now. So I've accomplished my goal yet again. I've eliminated the variable from one side of the equation. Now the variable is only on the other side, the side that I chose in this particular example. So now I have 6 equals 2. This can get tricky. What's x minus 4x? Remember that x has a 1 in front of it, so you can think of this as, what's 1 minus 4? Negative 3, negative 3x. So x minus 4x is the same as 1x minus 4x, or 1 minus 4, which is negative 3 or negative 3x. Alright, now I want to isolate my x, because that's the whole point here. Six divided by negative 3 is indeed negative 2. Let's go on 2. So x is negative 2. Did I get the same answer? Yes. Did it take me less steps? Yes. And this is why the book wants you to do it this way, because it technically takes less steps. I honestly don't like this right here, having to do an x minus 4x. It looks a little confusing to me. I prefer this method here, keeping my variable term positive, because here when I go with this route, I end up with a negative variable term. It's a bit confusing. So my preference is to get rid of the smaller coefficient variable term as opposed to the larger coefficient variable term. Either way, both are the right answer. You can choose either strategy. You get the choice. You get to keep the variable on one side. You can choose the side on which side you'll keep that variable. So we don't always get a choice in how we solve math problems, so this is one of the cases that you do. So that can be a good thing or a bad thing if you don't like choices. Alright, any questions here? Moving on to the next example. So this one's pretty similar to the last one. It's a bit bigger, but you're going to solve it the same way. And just like before, I'm going to show you both methods. And after this point, I'm going to stick to my method. And if you want to use the other way that you liked, you're more than welcome to. And oh, by the way, yes, you need to write this down. So I'm going to write this down. Okay, so first I'm going to start with the way that I like to solve these problems. And the way that I like to solve these problems is I'm going to choose the side which has the larger coefficient variable to stay. 9b, 5b, that's the smaller coefficient variable. The 5 is a smaller coefficient than 9. So I'm going to get rid of the smaller coefficient variable and I'm going to let this one stay. And in the next few minutes I'm going to show you how can you make this one stay and this one disappear? So how do I get rid of a 5b? How do I make a 5b disappear? Subtract the 5b. I do the opposite. 5b minus 5b, just like 5 minus 5, yields a 0, which is great. It eliminates that 5b for me. Nice, convenient. But I also have to do that to the other side. Do remember that, please. Don't forget. Although most of you are pretty good at this, so I'm not so worried. 9b minus 5b. That's pretty easy. Minus 6 carries over, equals to, this is now gone. It's a 0. I'm not going to write that 0 here because 0 plus 18 is just 18. There's nothing else on that side. You write that 0 because you have to equal to something. But since I already have that 18 there, I don't have to write that 0. You can't though. You can write 0 plus 18 if you really want to. Then I'm going to solve this just like a two-step equation again. I'm not going to spend a ton of time on this. Minus 6 plus 6 on both sides. For b equals to, that's going to give us 24, if my math is correct. Divide both sides by 4. That's a 1, 4 divided by 4, and 24 divided by 4 is 6. Perfect. Now let's do it the other way. And again, it's going to work out about the same way. Honestly, I could probably stick to either method. If I was told to choose the other method, I would be fine with it. It's just a preference with me. Something that I've learned over the countless number of problem types that I've done. Just this method is more familiar to me now. But now I'm going to keep this one and I'm going to get rid of this one. How do I get rid of a positive 9b or a 9b? Subtract 9b. And of course I got to do it from both sides. 9b minus 9b, just like 9 minus 9, that's gone, it's a 0. And I'm not going to write that 0 because I have that negative 6. 0 minus 6 is still minus 6. Now 5b minus 9b, and this is the only reason I don't like this method, is because 5, 9, the 9 is bigger and it's a negative term, so it's going to be a negative 4b. So here I always get a positive variable term when I go with my method. Here you almost always end up with a negative variable term. Then I'm going to solve this just like any other two-step equation. Plus 18, I'm going to deal with that by subtracting 18 from both sides, which here that's gone. Here it yields negative 6 minus 18 is a negative 24. They're both negative numbers, so they're going to combine. Negative 4b. Then I have to divide both sides by a negative 4, not just a 4, but a negative 4. And that's a 1. Negative 24 divided by negative 4, same sign division, yields a positive number always. Same answer. I didn't have to deal with any negatives here. So I don't know. I like my method a little bit better. But you're more than welcome to choose which one you like when you work the problems out on your own. Both are correct. Both are going to yield the same answer. Neither of them is really any more difficult in terms of number of steps they add. But I'm going to stick to this method from this point on when I solve the problems. And when you work on your own or do the quiz, if you want to go with this method where you eliminate the larger coefficient variable, please, that's up to you. Any questions before I move on? Alright, so this problem here, not very difficult. I'm gonna, well, here you don't have a choice. They're both the same coefficient terms, so it doesn't matter which one you pick. You gotta pick one. I'm gonna pick to eliminate this one. Doesn't really matter. And of course I gotta do it from both sides. Alright. Okay. So something interesting happens here. 9w minus 9w, that's gone. 9w minus 9w, that's gone. So what are we left with? A positive 3, or just a 3, equals to a positive 7, or just a 7. Is that right? No, that's not right. 3 does not equal 7 in any universe, including our own. So that's not true. So in this case, you write down no solution. Three does not equal to 7. That just doesn't work. So if you have a problem that you worked out and you know you worked it out correctly and you get something like that, no solution. That's not a possible answer. So that equation is wrong. This side does not equal to that side. So, nope. Alright, so that was a pretty easy one. I just wanted to throw that one in because there are cases like that, so that when you do get to that point, you're not like, did I do this wrong? No, you did it right. That's just a broken problem. And we do throw those in for fun. You might even see one like that on the quiz. For fun, of course, because we like to have fun. Alright, second to last problem. Yeah, we're breezing right through these, so this should be a pretty quick section. Alright, big problem. But not a bad problem, because you get to make this one smaller in one step. How can you make this? What would you do first? What would be your first step here? Hopefully, you said combine your like terms. Combine this, combine this. I'm going to mark this one too, but you can't combine this one with these two because it's separated by that wall. A few of you actually tried that on the quiz to combine all the terms regardless on what side of the equation they were on. No. You can only combine things that are on the same side. Then I have constant, constant, constant. And again, I can only combine these two, can't combine this one with the other two because different sides of the equation. It's like a wall that they can't scale, or like some kind of a barrier. Alright, 10z minus 4z. Covered that term up if it messes you up, because that minus sign belongs to the constant. So what's 10z minus 4z? 6z. And I have to write this minus 15 right here because I'm not going to be able to combine it with the constants on the other side. What's 8 minus 15? 8 minus 15 is a negative 7. And I have to write the minus 2, 7 because I can't combine that z term. Sorry, negative 7 minus 2z, and I have to write that minus 2z because I can't combine that z term with the other z terms. They're on different sides. Now it looks like a problem just like this one that we did just a little bit ago. Come here. Looks just like this problem right here. You have z terms on both sides of the equation, and you gotta choose a side and get rid of whichever z term that you choose. I'm going to choose to get rid of the one that has a smaller coefficient. 6z, 2z, technically negative 2z, but I go with the absolute value as far as size is concerned. This one's bigger, this one's smaller. So I'm going to keep this one, I'm going to get rid of this one. How do I get rid of a A negative 2z or a minus 2z. What's the opposite of a minus 2z or a negative 2z? Do you see that? I just added 2z to that side to get rid of this one here, because minus 2z plus 2z, kind of like minus 2 plus 2, is a 0. And I had to do that on both sides of the equation. That's gone because that's 0. Over here I get 8z minus 15 equals to, that's just a 0 now, so I'm not going to write it, equals to 7, a negative 7. Now I just solve this like a two-step equation. Isolate my z by getting rid of the minus 15, add 15 to both sides. Gone. 8z equals to negative 7 plus 15 is a positive 8, or just an 8. Divide both sides by 8 to get rid of this one here because it's being multiplied. The opposite is division. This simplifies to 1. 1 times z is z. We don't have to write that. And this also simplifies to 1. So I get z equals to 1. Yay! So, questions? This is about as difficult as a problem without fractions with this section will look like on the quiz. Oh, did I mention fractions? Yes, I did. You know you love them. Last problem. Fractions. So, think about this for a second and then tell me, how would you work a problem like this out? What would be your first step? And let me give you a hint. It should be just like you worked out the problems with fractions in the last section. If you said find the LCD, then you are very much correct. Congratulations. Find the LCD. And what is the LCD? It's 6, because 6 goes into 6. Technically this y is over 1, and 1 goes into 6. 2 goes into 6, 3 goes into 6. 6 is the smallest number that everything here will go into evenly. So that's our LCD. What's our next step once we found our LCD? You're absolutely correct. Multiply everything by that LCD. So now I got to distribute, because I got 6 being multiplied by everything on each side. So this 6 is going to get distributed, which it's going to look like this. So let me pause this so it doesn't take too long. Alright, so all I did here is I distributed this 6 to all of these 3. So 6 times y over 3, 6 times 3y over 3, 6 times 3 over 2, and I carried over the signs. Here I distributed the 6 to the y, and I distributed the 6 to the 7 over 6, and again that minus just carried down. My next step is to simplify if I possibly can. And in a lot of these cases I can. Now I can write this 6 as 3 times 2. I can do that. Which means I can cancel out this and this, and the 6 is gone. Here I can do the same thing. I can break down my 6 into 3 times 2, which will get rid of the 6 because 3 times 2 is 6. Those 3's are gone. Again, I can break down the 6 into, you see the pattern here. In this case, I'm going to eliminate the 2's, Again, this 6 is gone. Here, there's nothing to simplify that 6y, so it's going to stay. And here, both 6's are gone because top and bottom are both 6. You're getting multiplied by 6 and divided by 6 at the same time. So what's left? What is left? On the top here, I have 2 times y, nothing on the bottom, 2 times 3y, which is 6y, sign carries over, 3 times 3, which is 9, equals to 6 times y, which is 6y, and that's gone, sign carries over, 7. So take a second and digest this, and let me know if you have any questions of me going from here to here, how I did the simplifications or anything else. Because this is an important step. Although it's very similar to the steps we worked on in the last section. Okay, next I will eventually choose a side to keep my variable on because I do have y terms here and a y term there. But before I do that, I'm going to combine my like terms. In this case, I can combine the 2y's here. So 2y plus 6y is 8y minus 9 equals to 6y minus 7. Okay, so now I get to decide what side I will be keeping my y terms on. And as before, my preference is to get rid of the y term with the smaller coefficient. 8, 6, the 6 is smaller, so my preference is to get rid of this one. But again, if you wanted to, you could get rid of this one instead. But I'm going to get rid of this one. And I'm going to keep my variables on the left side as opposed to the right side. I'm going to take that choice. I get rid of a 6y by subtracting 6y. And I got to do it from both sides. That's gone. 6y minus 6y is 0, just like 6 minus 6. Okay. On the right side, I'm going to run out of space here. I have 8y minus 6y, which is 2y. Minus 9 is still there, equals to this minus 7. Then, and I am running out of space here, so let's see if I can finish this up. I have a two-step equation. I want to get rid of the minus 9 first by adding 9 to both sides. So 2y, that's gone. Negative 7 plus 9 is a positive 2. Then I would divide both sides by 2. And of course, I get to cancel out everything. 2, 2, 2, 2. That's 1 on each side, including the y. So y times 1 is y, equals to just 1. Came out nice and even. Again, this is really no worse than any of the fraction problems in the last section. And this is about, again, as difficult of a problem as you'll encounter on the quiz from this section. And you'll probably have one of these. Alright, any questions before we wrap up the 3.4 lesson? Okay, thank you very much for watching this. This will be online for you to view if you want to look at it again. But, alright, we're done.